These protocols can be incorporated into tension measurement protocols. For example, they can be used to measure equilibrium interfacial tension between water and oil phases. Each of the two protocols in this video can be used to obtain robust and reliable equilibrium surface tension values. These values can be established after testing their stability against area perturbations.
To begin, prepare the tensiometer and sample as described in the text protocol. Then, select an inverted stainless steel needle based on the estimated surface tension values and place it at the tip of the dispensing device. Next, load 40 milliliters of liquid sample into a quart cell. Place the cell on top of the sample platform. Adjust the height of the inverted needle such that the tip of the needle is at least 20 millimeters below the surface of the liquid sample. Inject 1 milliliter of air through the submerged inverted needle to remove impurities that could possibly be present on the tip of the syringe and to improve the surface chemical purity of the air-liquid interface. Then, experimentally determine the initial bubble volume. Dispense the computed initial bubble volume to form a bubble at the tip of the inverted syringe. Make sure that the bubble is in hydrostatic equilibrium such that the bubble does not move. Measure the dynamic surface tension based on the shape of the produced air bubble at the tip of the needle. Every second, calculate the surface tension based on the axisymmetric drop shape analysis method of the Laplace-Young equation.